Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're gonna be going over section 8.4, which is systems of nonlinear equations. Okay. So we have nonlinear equations, right? Which means we have equations that are not lines. Okay. How do we solve nonlinear equations? Well, you can do it by substitution or elimination as well. Okay. Now there'll be cases where you're not able to do both, which is a little bit different than systems of linear equations. Linear equations, you can always do either substitution or elimination. Nonlinears, that may not be true. Okay, so let's do an example where we're doing what's called by substitution. Right, so remember, if you want to do substitution, you want to get the letter by itself. So if I have y equals x plus 1, notice I have a y by itself right here, so I can plug it into here. Okay, so notice the situation at hand. Okay, so now instead of saying y equals x squared plus 1, I replace my y with x plus 1. It looks like this. And the reason why we do that is right now I don't have a y anymore. I only have one letter, which is x. Okay, now after that, right, it's pretty much things that we hopefully kind of know how to do, right? So how do we solve an x squared, right? We either do quadratic formula or factoring. We need to move all the things on one side. So I'll subtract. So I have 0 is equal to x squared minus x. So that means I can factor this. I can pull out an x minus 1, set both of them equal to 0. So I have x is equal to 0. And I have x is equal to 1, right? If I set both of them equal to 0. Okay, so let's talk about this right here. So now the thing we need to be a little bit careful is we need to talk about each situation. What happens if I plug in 0? What happens if I plug in 1? Okay, and we can plug it into either equation. So for example, I could plug in this second one. But I want to talk about each scenario first. Okay, so I'm saying when x is equal to 0, right, I'll plug into either of my equations, kind of like what we've done before. So I have y is equal to x plus 1, which will be y is equal to 0 plus 1, which is 1. Okay, so that means I have a coordinate at 0, 1, right? Because when x is 0, y is 1. Okay. And then I'll write the second part. Well, what happens when x is equal to 1? I'll plug it into here, and I have y is equal to x plus 1, y is equal to 1 plus 1, y is equal to 2, and this is 1 comma 2. Okay? So that means those are my two solutions. Okay, and this is important. You want to make sure you actually write the coordinate, because you can't say x is 0 and 1 and then y is 1 and 2, because otherwise then you're saying like 0 comma 2 or 1 comma 1 would work. So make sure you guys understand, right? So it's not just any combination of when x is 0, 1 and y is 1, 2. It's when it's specifically 0 comma 1 and just 1 comma 2. Okay, so you can also check, you can plug by plugging in both, or you can also check by graphing. So I can graph y equals x squared plus 1 and y is equal to x plus 1 and graph both of them. And so I want to see where they intersect. Actually, let me zoom in. So I'll hit zoom and I'll do option 2. I'm going to zoom in on the origin. So just to kind of see, okay, so remember how do we do intersection? You go to second trace, go to intersect, option 5, and then move your cursor to where your two graphs intersect. And then, so move your cursor to where the two graphs intersect, and then hit enter 3 times. 1, 2, 3. So notice they intersect at 0, 1. I can do the same thing. And then I can move it over here where I can clearly see they intersect. And I'll hit enter 3 times. 1, 2, 3. And I have 1 comma 2. And that makes sense. Okay. Let's do another example for the following. Let's go to number 3. Okay. So this one will also require substitution for the following. Okay. So I notice y is by itself. I can plug my 2x plus 4 in for y over here. And it looks like this. So I have 2x plus 4. Sorry about that. So instead of saying y, I have 2x plus 4 is equal to square root of 4 minus x squared. And then I can square both sides. This is 4 minus x squared. Okay, right? I square both sides. Now, if I'm squaring both sides here, right, I'm going to FOIL this. Okay, so as you can see here, as we're kind of working along, okay, it's kind of like a lot of problems we've done. So the difficulty is not necessarily anything new. It's just a lot of things you need to make sure you know how to solve, like radicals, quadratics, and so forth. So we're going to distribute. So this is 4x squared plus 8x plus 8x plus 16 equals 4 minus x squared. I have 4x squared plus 16x plus 16. I'm going to add x squared to both sides. So I have 5x squared plus 16x plus 12. Let's see, this factors into 5x and x. And let's see. Yeah, it'll definitely be 2 and 6 here. We'll solve by comparing both of them to 0. And I have these two values right here. So let's talk about it. So we say when x is equal to negative 6/5, and when x is equal to negative 2, we'll plug them both in. So here's the thing, you can plug into either one, but obviously we want to plug into one that's easier to solve, right? So I don't want to plug into the first one because I'm going to have some crazy stuff where I have to deal with a radical. So it's a lot easier to plug in the second one. Okay, so that is negative 12 over 5. I can write 4 as 20 over 5. So this is 8/5. So I have negative 6/5 and 8/5. And if I plug in negative 2 for x, I'm going to get y is equal to 2 times 2 plus 4. So I have negative 2 comma 8. Okay. Okay, I'm going to skip over several pages. Yeah, a lot of extra ones. Try to see if you can do some of those by yourselves. But you can also do systems equations through elimination as well. Okay, so let's talk about this. So let's look at example number 1. So how do I know I can do this by elimination? So if you notice I have x squares and y squares, so I can try to get rid of one of them. Think of it just like a regular 2 by 2, only this time we have x squares and y squares. I can clearly see I can't do substitution because if I wanted to get y by itself, I have to take the square root, and that's going to be kind of tedious. So that's why it's easier for us to do elimination. So what I want to do is let's eliminate y. So 12x squared plus 4y squared is equal to 124. So this becomes 13x squared equals 117. Divide both sides by 13. That will be 9. Okay, and I'll take the square root. Be really careful when you take the square root. You're doing plus or minus. Okay. So let's talk about this here. So when x is equal to 3, we can plug it into the first equation, right? So I have x squared minus 4y squared is equal to -7. Sorry, let me deal with this. So I have 3 squared minus 4 times the quantity y squared equals -7. So I have 9 minus 4y squared is equal to -7. So I have -4y squared is equal to -16. I'll divide. And then I'll take the square root. Be careful once again if I take the square root. This is plus or minus 2. So that means I'll have 3, 2, and 3, -2. Okay? So those are my answers. Now we'll do the same for -3. Now, as you can see, this is a lot of work, okay? But let's notice what happens if I plug in -3, right, in for my first equation. So I have x squared minus 4y squared is equal to -7. I plug in -3. And one thing I should realize is I actually have the same result as my last one, right? I also get 9 minus 4y squared equals -7. So that means everything from here on out is going to be exactly the same. And I will also get y is equal to plus or minus 2. So the way this will end up is going to be this. It's going to be, I will also get -3, -2, and -3, 2. So I actually have 4 solutions, okay? And it's really possible that you'll have many, you'll have many types of problems. Or sorry, many types of solutions in your problems, right? You might have like 4, you may have 6. It is really possible to get those. That's pretty much it. Okay. So let's take a look at, let's just do one more example. I'm going to scroll all the way down. I'm going to do number 7, which is actually the same as number 6. So I want to do this one because this one's a little bit trickier. So you want to make sure everything is lined up, kind of like elimination, if you're doing elimination. So I have 5 over x squared minus 2y squared is equal to -3. And I have 3 over x squared plus 1 over y squared is equal to 7. Now, this is a little, this may be confusing for some of you guys, right, because the y squared is on the bottom, okay? But here's the idea, right? If I want to do elimination, right, if I multiply this by 2, right, I'm going to get the following. Let me rewrite the top part here first. Okay, so I'll combine them. So this actually goes away. And so 5 plus 6. So remember, right, they have the same denominator, so you add the top. So this will be 11 over x squared equals 11. I will cross multiply, which will be 11 is equal to 11 x squared or x squared is equal to 1. Then I take the square root. And so essentially I have x is equal to plus or minus 1. Okay? So we're getting the same kind of like case by case scenario. So we're like, what will happen when x is equal to 1? So when x is equal to 1, let's plug it into the bottom one. So I have 3 over x squared plus 1 over y squared is equal to 7. So 3 over 1 plus 1 over y squared is equal to 7. So 1 over y squared is equal to 4. Cross multiply. I have 1 is equal to 4y squared. I'll divide. And I'll take the square root. And I have y is equal to plus or minus 1/2, right? So what does that mean? So when x is 1, I'll have 1 1/2. And I'll have 1 negative 1/2. Okay. Let's see what happens if I have when x is equal to negative 1. Here's a thing too. This is also, you can save work for the following. Notice you end up having the same result. So this goes to the following. I also get y is equal to plus or minus 1/2. So I have negative 1, 1/2, negative 1, negative 1/2. Okay. So that's pretty much it. Okay. So let's just talk about how do you know when to use elimination and how do you know when to use substitution, okay? So if I do the following here, okay? So if I look at example like number 1, okay, it's a lot easier to use substitution, right? Because I can say I can replace y with 8 minus x and then solve from there. If I had to do elimination for 1, right, number 1, the only thing I can eliminate is y, right? Because I could subtract. But I cannot do x because I have to either square both sides, and then I have x squared and x, and I can't cancel that. Okay, so number 1, do you see that I would use substitution, or I can do elimination by x. Okay. Like now for number 3 here, do you see this? So if you guys notice, I cannot do elimination, right? Why? Because notice if I subtract, there's no way I can get rid of x or y separately for the following here. Okay? So you want to make sure you know how to use, when to use different ones, okay? And some of them are pretty clear versus others, okay? For the following. Okay, so I think this should be enough, okay? If you guys want me to do more practice, feel free to email me, okay, or we can kind of talk over discussion forums. You guys have to just kind of do several of them to get into practice, okay? And then remember, you can also check for some of them by graphing them and then finding their intersection. So that's 8.4. We'll end there.